Alright, let's focus on quadrantal angles. Let's find sine 90. Let's describe two approaches to doing this. First, we can simply sketch the actual function. So sine, I recommend you go pow. For teeth, sine goes up, goes down, and goes up. It almost looks like a quarter circle. It curves. And it keeps on repeating up and down, up and down, up and down. It even goes towards negative land. But this is 0 degrees, this is 90, and the maximum height is +1, and the minimum height is -1. This is 180, this is 270, this is 360. So the first full period of sine is up to 360. If you really want to draw more, you can go pow, and you can see that it curves up, it curves down, and curves up, and this is a sinusoidal function that repeats forever and ever. All real numbers is the domain. Alright, so sine 90. Sine 90 means when the angle is 90 degrees, what's the y value? Sine 90 is 1. The x value, or the theta value, is 90 degrees, and the y value is 1. This is a coordinate, it's a point on this sinusoidal function. Okay, so rather than drawing this sideways, you can also think of this as a wheel. You can graph a circle. And you can start at the right here at 0 degrees. So theta is increasing and it spins around in a circle. And this is a unit circle. This happens to be +1, -1, +1, -1. And if you just rotate with the circle towards 90 degrees, sine is the y value. So let me try to convince you of that. Let's just draw a random right triangle here. We'll call this theta. And suppose theta is in this position here. And we'll call this some point on the circle. We'll call it x comma y. So y is the physical height, and x is the x value of this coordinate. We'll call this x. What is y? The y value, the height of the triangle, has a connection to SOHCAHTOA. This is the unit circle. It has a radius of 1. So sine theta is opposite over hypotenuse. Sine theta is equals to y, the opposite of the triangle, the height of the triangle, over 1, the hypotenuse, the radius of the circle. You know that anything divided by 1 is simply itself. So from now on, for the unit circle, please memorize that y equals sine theta. Just memorize it. This here is radius 1, radius 1, radius 1. The radius is 1 all the way throughout the whole circle. Alright. Similarly, using SOHCAHTOA, we know the x value is always cos theta. Cos theta is adjacent over hypotenuse. Cos theta is equals to adjacent x over hypotenuse, x over 1. So from now on, memorize x is cos theta. Alright. That was a bit confusing, but we'll memorize some patterns and the math will be very mechanical. Y is sine theta, x is cos theta. So we know that theta here is 90 degrees. Let's go all the way to this point over here. So we know that this is going to be x comma y. And we can see right away that the y value, we memorized previously, the x value is cosine theta. And we know that the y value is sine theta. The y value is sine theta, and we know that the radius here is 1. We know that the y value is +1. This here is +1, and going down to negative land would be -1, but we're at +1. So by simply spinning the wheel, we can quickly locate the point and quickly identify these quadrantal angles. These quadrantal angles fall either at the top of the circle, the bottom, the left, or the right. So it's very easy to spin the wheel and see what the answer is right away. Let's try cosine 180. So using the wheel analogy, we go to 180, which is here. Cosine, memorize. We're talking about the x value, not the y value. Cosine means the x value. And the x value is not positive 1, but negative 1. So this is pretty fast. So please memorize that x is cosine theta. Think of Vladimir Putin in Russia, going from coast to coast across this very big country, the biggest country in the world. Whereas sine is concerned about going up and down. What happens to the student who bullies other students? Perhaps they go up, perhaps they trip on their graduation and fall down the stairs. Bad karma. If you're a very visual graphing type person, you can also graph cosine. Pow. Cosine starts at 1, and it looks similar to sine, but it starts at 1 instead of 0, and it also goes up and down. It's actually the same graph, it's just shifted 90 degrees. So this is 0, this is 90 degrees, 180, 270, and we just sketched the first period of cosine. And it keeps on going, by the way. It keeps going up and down. So cosine 180, you can see clearly the answer is, the y value is negative 1. So let's try sine negative 360. You can either extend this graph to the left, or why don't we just try spinning the wheel? We're just going to memorize that sine is the y value. So let's spin around, vroom vroom. Starting from 0, negative 360 goes clockwise all the way around, and the y value is not 1, it's 0. Because we're concerned about the height, not the position left or right. So do not mix going sideways with up and down. The actual height of you on this Ferris wheel is 0. Now what about tan 180? What's tan 180? So one way of doing this is to memorize a very basic trig identity that tan theta is equals to sine theta over cos theta. We know that tan 180, when theta is 180 degrees, is sine 180 over cosine theta, which is cosine 180. And previously we learned how to do these. What's sine 180? We start at 0 on the right. We go 180 degrees counterclockwise. What's the y value? Is 0. So it's going to be 0 divided by, who cares? 0 divided by anything is generally 0. But let's just, for the sake of completing this, let's think through cosine 180. So we have a circle here. 180 is here. The x value is negative 1. 0 divided by negative 1 equals 0. So tan 180 is 0. In a future course, you'll be responsible for actually graphing tan function. So let me just plant a seed. Y cos tan theta. What does it look like? Next year you'll be drawing this a lot. It does not look like sine and cosine. Instead of pow, we just say pow. The period of tan is 180 degrees. We'll say 90 degrees and 180 degrees. And there's a vertical asymptote every 2 teeth. So the next vertical asymptote is 270, and we can go to negative 90 degrees, and there's another vertical asymptote here. But the period literally launches towards infinity and beyond, and you reappear off the other side of the universe, and then you land your rocket like this. And the whole thing repeats again towards infinity. There's a vertical asymptote here, and towards 360 you land. So it looks almost like a star, or you can think of the tan function like an S if you extend it backwards. But this repeats, and this beautiful pattern comes about by simply dividing sine divided by cos. So bottom line is, this is what the graph looks like, and it's nice to memorize that tan 45 is 1. Tan 45 degrees is equals to 1, but we're not very responsible for memorizing this graph at this particular course. But just for the heads up, it's coming up next year. Okay, so the question was, what's tan 180? You can see visually here, the answer is 0. So there you go. The answer is 0. Alright, it's your turn.